Good morning students. Last class we have discussed about alpha principle. So this class we will see about Pauli exclusion principle. What this rule says. Pauli exclusion principle, which is nothing but no two electron in an atom can have same value for all the four quantum number. This is the definition for Pauli exclusion principle. We will explain with example. Okay. Before explaining the Pauli exclusion principle, you should know what is quantum number and what is orbital. Already we have studied in lower standard and what is quantum number. Okay. We are having four quantum numbers: principal quantum number, azimuthal quantum number, magnetic quantum number and spin quantum number. First of all, what is quantum number? Quantum number describe the position and energy of the electron. So, principal quantum number is denoted as N and azimuthal quantum number is denoted by L and magnetic quantum number is denoted as M and spin quantum number is denoted as S. Okay. These are all the four orbitals. These values only we are going to find out for Pauli exclusion principle. Then we move on to orbitals. What is orbitals? We are having four orbitals: S orbital, P orbital, D orbital and F orbital. So in S orbitals, how many electrons can accommodate? In S orbitals, only 2 electrons can accommodate. So in P orbital, how many electrons can accommodate? In P orbital, totaling 6 electron can accommodate here. 1, 2, 3, 4, 5, 6. In D orbital, totally 10 electrons can accommodate. So let me write the electrons: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In the same way, for F orbitals, we are having totally 14 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. So, for S orbital we are having 2 electrons, for P orbital we are having 6 electrons, for D orbital we are having 10 electrons, for F orbital we are having totally 14 electrons. Okay. So, let us take one example. I am taking the 3D orbital to explain the Pauli exclusion principle. Already we have seen that in D orbital totally we are having 10 electrons. So, in D I am taking the D orbital. So, I am writing the 10 electrons here. How can I write the electrons inside the degeneracy box? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. In this way I have to fill the electrons in the degeneracy sets. So, this orbital is called degeneracy set. What do you mean by degeneracy? Degeneracy means the orbital is having the same energy. Okay. So, let us find the values for all the four quantum numbers. We know what are all the quantum numbers. N, which is nothing but the principal, and L azimuthal, and M is magnetic quantum number and S is spin quantum number. So, let us find the values for each quantum number. Here we have to find the value of N. So, I have taken 3D orbital. In alpha principle itself, I have told how to find out the value of N. The number which is denoted before the orbital. Here it is the D orbital. So, what is the number which is before the orbital? We are having number 3. So, the value of N is 3. Okay. So, then we have to find out the value of L. L, which is nothing but what? Azimuthal quantum number. Last video itself I have covered the value of L. So, L value for S orbital is 0, for P orbital is 1, for D orbital is 2, for F orbital is 3. So, this is the value of L. So, in this case, what is the example I have taken? D orbital. For D orbital, what is the L value? 2. So, let me write the value here. Then I have to find out the M value, magnetic quantum number. For that, I am drawing the degeneracy set. Since it is a D orbital, it will be having 5 degeneracy set. So, I am filling up the electrons 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, these are all the electrons which accommodate the D orbitals. How can I find out the L value? Here the center one will be having the positive 0 and this is plus 1 and this is plus 2 and this side minus 1 minus 2. Here what they are explaining, this 2 electron is having the value of M is minus 2. Then this 2 electron is having the value of M is minus 1. This 2 electron is having the value of M is 0. Then this 2 electron is having the value of M is plus 1, for this plus 2. Because since it is a magnetic quantum number, each degeneracy sets having the different value of magnetic quantum number. Then the fourth one, I have to find out the S value. S, which is nothing but the spin quantum number. Okay, let me write one box alone. It's a degeneracy set. If the electrons are filled, so the first electron is said to be the plus half and the next electron is said to be the minus half. So, the S value will be plus half and minus half. For M value, let me write minus 2, minus 1, 0, plus 1, plus 2. And this is the M value, and N value will be 3 and L value will be 2. Okay, in this way we have to find out the value for all the 4 quantum numbers. Okay, finally what this rule? No 2 electron in an atom can have same value for all the 4 quantum numbers. Okay, here the values will be different because we are having the all 4 quantum numbers. See the value. For N we are having 3, for L we are having 2, for M we are having the different set of values, and for S we are having plus half and minus half. So, the next topic we have to see Hund's rule of maximum multiplicity. Thank you.